Okay.
All right. So sorry everybody for being late. I'm only 2 words Deutsche Bahn, so that's it. Today I will be talking about the topic of teaching Rust, and I hope that you are interested in this topic and that at the end of the talk you will start some initiatives to also teach Rust at your organizations. So my name is Mo, also called Mobit on social media and GitHub and so on, but 8 instead of B because that's cool. So in this talk I will first start with the resources available for teaching Rust, and then I will talk about teaching courses which are made up of multiple days. And finally, I will also mention teaching Rust in another format, which is a workshop. Workshops are mainly done for 3 or 4 hours, so that's a different format, and I will be also talking about that. So a little bit about me. I think this background is perfect for me. This is where I come from. I started with physics, then I found out that I'm a computer nerd, so I started with computational sciences, and now I'm done and did a complete shift to computer science. So now I'm starting my PhD in programming language research in Mainz. And to put you in some context for this talk, I'm the maintainer of Rustlinks, which is a program that allows you to learn Rust interactively by offering you a set of exercises that you can do and get some feedback from the compiler while doing so. And as already said, I teach some vacation courses in Mainz at my university. I'm not sure if I will be teaching them in the future because of my new PhD status, but we will see about that. But I will definitely share my experience doing that. So, what kind of resources do we have for Rust? For learning Rust, we already have many decent learning resources. So there is, of course, the Rust book. Everyone is familiar with it. It's available for free online. You can also get a printed version if you are really into touching paper. But other than that, it's available online for free. And there is also Rustlinks, which I just mentioned, so that you can get some practice. The Rust book is rather theoretical. It has some example, but if you want more examples, then there is also Rust by example. And finally, there are other books like Rust Forestations, but they are mostly targeted to people that are already familiar with the basics. So I always recommend starting with the Rust book and doing Rustlinks along that. And then you can think about continuing with other books. What about teaching resources? I mean, that's what the talk is about. And for teaching, we don't have many resources, but we have 2 very decent ones. The first one is Teach RS. It has been renamed from Rust 101, in case you have heard of that. And it's a university course. So if you want to teach Rust at your university in the frame of a whole semester, then take a look at that. They have slides and exercises and so on. Very well organized. I highly recommend it, but I didn't try it. So what I will be talking about is Comprehensive Rust, which is a course designed for a couple of days for getting you started with Rust and teaching you the basics in a crash course fashion. So Comprehensive Rust is designed by the Android team at Google, and it contains 4 days of what they call Rust fundamentals. These are the basics, but also the unique and important aspects of Rust, for example, ownership and borrowing. These are covered in the first 4 days, and there is 1 day which talks about concurrency, which includes multi-threading and async. Also something interesting that I taught. But the other 3 topics that they offer are they are too specific for me. So there is about Android, Chromium, and bare metal. If you are into any of these, then you can take a look at them, but otherwise I would recommend that you exclude them for teaching, especially in the university. And for teaching comprehensive Rust, you have this website, and I will show you an example. Every day is split into a morning session and an afternoon session. And after each session, you have a set of exercises. And what is special in comprehensive Rust is that you have these code snippets, but they are also interactive. So you can go there, modify the code, and then run it. And after that, you will get the result printed out below. This is very useful, especially when you are explaining something. Then you can just go there, change something, and see how the output changes. And you can much better respond to questions from the students. One another important note is that you have the speaker notes. You can open them below, but if you have another display, then you can also open them on a completely separate display. And these are basically meant to be read by the speaker. So what is above is like the slide, and what is below is for you to prepare the slide and maybe mention some stuff that isn't on the slide. Here is, for example, another example, so you can see what other aspects are related to this topic. So, highly recommended, comprehensive Rust, and the maintainers are very friendly, by the way, so shout out to them. And now I will talk about Rust links, and if you haven't seen it before, then you will see here that for getting started with Rust links, all what you need to do is first install Rust and then run cargo install Rust links. I have already done that, but for the rest of how you get started with Rust links, I'll do that here live. So you have Rust links installed, and now you say Rust link init. This will tell you I'll create a directory which is called Rust links. Okay, go ahead. Now it tells you to go into this directory and then run Rust links again. So if you take a look first, then we see we have 2 directories inside, exercises and solutions. And the solutions are only displayed to the user after they have done an exercise. This is also something important. So your users or students won't be spoiled. That's something important. And now let's just run Rust links inside of this directory. It will first show you some introduction, but we'll skip it for now. And now it will be showing you the feedback to the first exercise. And the first exercise is already done, but it will just introduce you to how Rust links works. So let's open the file of this exercise. It's called intro1. And you see here, it only contains some print lines. And actually it tells you that the exercise is already done. So you can go ahead and press N. And with that, we are on the second exercise, which is intro 2. So let's go ahead and open it. And we see in our editor, of course, you can use VS Code or any other editor. I'm just using Helix here. But in your editor, it will already show you some of the compiler errors. But Rust links also shows you these errors above, and you can also ask for hints if you don't know what to do. So if you want to ask for a hint, you can press H, and then a small hint is shown to tell you what to do. And after solving this, Rust-Links will recompile your exercise, and if everything is done, you can move on to the next one. So you can take a look. It has many exercises, about 100, and you can also skip some of them in this list mode or go back. So that's something that might be important for users that are more advanced in Rust, but they just want to refresh some aspects. So you can then skip the first exercise that are rather easy, and the difficulty gradually increases, so you can start with the ones that you want to work on. So that's it about Rust-Links. You can use it in your course, and that's actually what I've done. But first, let's talk about what you can do with these two resources that I've used, and because they are free and open source, you can just fork them. So if you want to add, remove, or modify these resources in any way, then you can just go ahead and do so. For example, this Google course, Comprehensive Rust, I removed some of the aspects that I don't need, and I added some others, reordered some content for the audience that I have, and then I hosted my own version, basically. And I also replaced the exercises of Comprehensive Rust with the exercises from Rust-Links, so you can mix these resources. And at the end, just make sure to publish your fork so that others can benefit from your work and from your remix. And don't forget to contribute to upstream if you have found some issues or if you have any suggestions for improvements. So I've already mentioned Comprehensive Rust and Rust-Links as a mix that I found to be very effective. And here I will show you my version of Comprehensive Rust. So you see here they are split into 2 sessions again. So day 1, we have here this morning session where you have some content and finally the exercises. And then afternoon has also some exercises. So if we take a look at the exercises of the first day, then it will tell you to install Rust-Links and then do all of these exercises. So that's what I would recommend to you if you are planning on teaching Rust for multiple days. Use Comprehensive Rust and combine it with Rust-Links. Or if you don't want to combine it with Rust-Links, fine. I mean, I'm biased. You can use the exercise that Comprehensive Rust offers as well. Okay.
Sorry?
Yeah.
Do you have your remix available online? Comprehensive Rust plus Rust-Links, what you just mentioned?
Yes, it's available online on Codeberg, so you can check out the repository on Codeberg. And it's also hosted, so it's comprehensive-rust.mobit.com. But I can share the links with you later. Oh, yeah, of course. So it's already there, but just keep in mind I didn't create this course because I want to emphasize this is a course created by the Android team at Google, and I just made this remix. So there is a disclaimer when you open it. So let's talk about these vacation courses that I gave for 3 times now. One of these courses is combined of 5 days, so a whole week basically, and every day we have 7 hours, so it's quite intensive. Some people like to invest their time and their vacation in learning something like Rust, which I find wonderful, but otherwise you need to see how to motivate people to join such a course. So it's split into 2 sessions, and that's what I would recommend. So first you have theory, then you have exercise, and then you have a lunch break for about 45 minutes. And then you have theory, exercise, and then you end the course. Why am I talking about this? Because when you are teaching a course like this, in general, when you are teaching about programming languages, then you have people with very different backgrounds. And some of them are more advanced, some of them already have knowledge in Rust, for example, but they want to build on this knowledge. And some of them only know Python. And that's not bad, but I mean, they miss then aspects like what is the stack, what is the heap. They need to learn all of this, and when doing the exercises, they might need more time. And for that, I found this format to be very effective. So if someone is already done with the exercises of the morning, then they can go and have a longer lunch break. And at the end, in the afternoon, they can just go home. And people that need more time can stay, and I can focus on them. So highly recommended that you do this split. Okay, and to spice things up, I did also some gamification. So at the beginning of the course, users register with some anonymous username. Here you see a screenshot as an example. And after doing these exercises, Rustlinks exercises, Rustlinks checks that you have done the exercise and everything compiles and all tests pass. And in that case, you get a point. And this point is then sent to a server. And on the front in the classroom, I show such a leaderboard. And believe me or not, you would say people aren't children, but it's really motivating. And if you show such a crap for people that have the highest score, then they freak out. It's really something that you should try. Give it a try. And I mean, gaming, right? It's all about scores. And if you see that you have more points, then you have more motivation. So if you are also interested in the code for the client server and this leaderboard in the terminal, you can also contact me. You can integrate it in your learning resources then. So some tips for you if you want to teach such a course. Don't reinvent the wheel. Use the resources that people have created. And if you take a look at the repository, for example, of comprehensive Rust, then you see that it's an effort of multiple years. So what you would come up in a couple of weeks won't have the same quality as what comprehensive Rust has. And it always involves some feedback loop, so you won't have this unless you teach this course for multiple times. So just benefit from what people have learned and use the resources available. And before starting the course, when you are advertising, be explicit about your requirements. Because if you want to teach a course about Rust, which is a rather advanced programming language, and you have a person that is excited about learning how to program, but they have no experience whatsoever in programming, then that will be very hard. So normally what I would recommend to you is that you require at least some knowledge in Python or a similar language. So people already know what variables are, what are functions, what are for loops, and so on. So you don't need to explain these aspects, and they already know the idea behind programming. That's the least thing to have, and you need to be explicit about that. And you should know your audience. So 2 points are very important. What prior knowledge does your audience have? This is important so that you can know what should I focus on, what should I maybe skip, and so on. And know about what your audience is interested in and what their expectations are. For example, I've told you my background is from physics, and I've given a workshop for physics students. And if you are working in theoretical physics, then what you are mainly interested in is having high performance. So you are interested in the maximum performance, but you don't really care about, let's say, abstractions, pattern matching, or whatever. So this is not really your focus. You want to write the most performant software, and maybe you hate C++, so you are looking for something else. So know your audience. What are they interested in? Why are they here? What do they expect? And focus on that. So you can then definitely focus on offering something about concurrency, because if they are interested in high performance, then they want to know how to do multi-threading, for example. Otherwise, you can skip concurrency and talk more about the basics. So, okay, so the course has started. What should you do? At the beginning, use the method of showing hands. So you just ask who here is familiar with Python, and people show hands. Who here is familiar with C++, and so on. This already gives you a brief introduction to what people know and what they might not tell you in the short presentation round or introduction round. So what I would recommend is, after this showing of hands, go ahead and, of course it depends on the number of people there, but go ahead and do some introduction round where everyone says their name and what they study, maybe what they are working on or whatever, and what languages are they familiar with, what are their expectations. This is important so that you can adapt during the course. Then gather some feedback, especially after the first day. It's not only about what people think about your course, it's also about human things. So people might need more breaks, or you should just slow down while speaking, or you should stop showing too much live coding, which is the next point. So get some feedback, especially if you are doing this for the first time. That's very important for improving the experience for your students or users in the next days. And the next point is, as I said, live coding. I've shown you this in comprehensive Rust. Do some live coding if you have the time for that, and it's really, but don't make it too complicated. So if you want to show some example, it should fit on the screen. That's kind of the measure that you want to have. Otherwise, people get lost. So live coding, definitely yes, but don't make it complicated. Topics to focus on, especially when teaching Rust. Ownership and borrowing, especially because this is a unique topic when talking about Rust. But there are also other topics that aren't really unique to Rust, but you also don't find them in every programming language. So enums, pattern matching, iterators, traits, and composition. Basically what is shown here is what people, from my experience, have problems with because they aren't familiar with these concepts. So what I recommend in this case, show examples and try to build a connection to what people are already familiar with. For example, when talking about iterators, start with list comprehension in Python. I mean, it's easy, it's understandable. Show them what you can do with list comprehension in Python, and then compare it to Rust and show them how you can get much further with iterators in Rust. So that would be one thing. And people will ask you about object-oriented programming, especially if they have some computer science background, because for them, object-oriented programming is the way of abstraction, and you need to explain to them, we don't have inheritance, that's a good thing. I will show you how to achieve what you have been taught using composition. So take an example and code it live, then they might get a better understanding of composition, because it's really something that is rarely taught at universities, at least. So, all right. So, finally, one final tip is focus on why people should be using Rust to keep them motivated. And I'm not only talking about the introduction at the first day. On the first day, of course, you need to tell them why are we here, what is Rust, what is unique about it. I'm talking about while you are teaching, not only on the first day, bring up some examples from other languages and show them how Rust is able to solve problems that you have in these other languages. So let's take a look at this actually very short and actually trivial example. This is Python code, and you have a list with the items 1, 2, 3, and then we have this loop. So one question is, what would you expect as the output of this program? Okay, so it has been said, infinite loop, but I'm sure you weren't that sure about it, and you would go ahead and execute it first, because it actually isn't trivial, because we are iterating over a list and modifying it at the same time. This is what is called iterator invalidation. And you might say, okay, that's easy. I mean, I'm appending to a list and I'm iterating over it. If you understand how this for works in Python, then you can figure this out. But then take a look at this second example. We have a list with 1, 1, 2, and 3, and this loop. And my question is now, what is the content of L at the end of this program?
Get an exception, right?
No, 1, 2, 3, I think.
9.
2, 3. 2, 3. No, 2.
Okay, so who is expecting 2, 3? All right, a couple of hands. Who is expecting 1, 2, 3? Because I've already heard that. Okay, also a couple of hands. And who is expecting something completely different? Okay, what are you expecting actually?
I think you get an exception because it's checked that you don't modify it while iterating.
That's also interesting thought. So you would expect an exception because you are modifying the list while you are iterating over it. But that's not a thing in Python. So what you will actually have at the end of this program is 1, 2, 3, and this is something that at least half of you didn't expect. So what is going on here is first, you see the first item 1 and call remove on it. So the first item is removed, but you are iterating here, and the index is 1. So you take a look at the index 1, but it's not 1 anymore, it's 2 now. So the next item in this iteration is 2, and you missed one item, which is 1, and you would expect that it gets removed. And here you see it's really not trivial, and this causes some non-trivial bugs, although it's actually a very small snippet of code. And that's, again, iterator invalidation. And if you show such examples after explaining ownership and borrowing, then people will stay motivated and understand the motivation behind it. why are we talking about this? Because some people will tell you, I won't be writing low-level code, and I'll just clone everything. I don't need to understand ownership and borrowing. But you actually should, because it prevents many bugs. So always keep in mind, why are we using Rust? What unique features does it have? And how does it compare to other languages? Okay. And finally, I will talk about the other format, which is a workshop. A workshop is a one-day thing, so 3 to 4 hours, I would say. And I have taught 2 workshops. The first one was in a summer school, as I mentioned, with physics students doing their PhD. And the other one was recently in the Chaos Communication Congress with Leonie, so shout out to her. And they were very successful, especially at the Congress. There were way too many people willing to get into the room, so many people had to be sent back. So if you are interested in advertising Rust and teaching people Rust, there is a lot of interest. So go ahead and offer such formats. But what would you expect, or what would I recommend when teaching such a workshop? First, start with the basics. So teach about variables, control flow, so if, else, maybe pattern matching, but don't overcomplicate it. Functions, primitive types, product types like array and tuples. And finally, I would end with collections, so you can teach about, for example, string and vector. Maybe hash map if people are interested in that, but I would stop there and leave the time for people to practice. And for the practical part, I would recommend using Rust links again. And that's what I have used in the Congress. It was a very good combination. So people started with the first couple of exercises, and so they finished 20 of them. And at the end of the workshop, we just said, continue this at home. But of course, you need to read about topics like ownership and borrowing on your own. So that would be what I talk about on the next slide. It's about tips. Of course, know your audience again. As I said, if your audience is from physics, they are interested in high performance, then talk about concurrency. Show Rayon, for example. You will not be able to explain everything about how Rust prevents data races and so on. Don't make it complicated, but show them an example of how Rust can make their life much easier. And also include the selling points at the beginning of your talk. So people are there not only to learn Rust, but also to maybe flirt with the idea of learning Rust in the first place. So you want to sell them Rust, so talk about productivity, reliability, and performance. These are the 3 features mentioned on the website, but don't waste too much time on that. And one very important point is, don't teach ownership and borrowing in such format. You will not be able to give a proper introduction into ownership and borrowing. So avoid talking about owned values, about references, and so on. And instead, maybe just mention it and tell people that they should do proper reading to be able to understand it. So for this case, refer to the chapter in the book and tell people that they need to do that at home. Trust me, it's much better than explaining things and leaving people with a wrong association. Sorry? Okay. And as I said, avoid details. You are just giving a first impression of the language, and it's not really important to talk about how things are done in the background. So keep it simple, and also keep your code snippets short. Otherwise, people get lost. At the end, recommend the book, and if you are using Rust links, recommend finishing Rust links. So again, that's the feedback that I got at the end of the workshop in the Congress. People said, I was willing to learn Rust for a long time, and this is the Kickstarter that I needed. So they start with Rust links, and they know the basics, and then they can continue on, finish the course, and read the book, and so on. All right, and with that, we have the conclusion. If students are able to learn Rust in 5 days, and some of them only have some experience with Python, then I would say that Rust is definitely not complicated. And it doesn't mean that Rust is easy, but it basically requires people to learn about new concepts before getting into code. Because some people, I've also seen that when doing Advent of Code, for example. Advent of Code is set of puzzles that you do in December. Doesn't really matter, but some of them use these puzzles to learn a new language. And I've seen some of them, especially on Mastodon, failing at learning Rust using by starting to code, because they don't really know how things are working in the background. What is ownership and borrowing? Why is the compiler telling me that something is moved? First, learn the basics. This is required in Rust. This is not Python. This is not Go. Learn the basics and then start with coding. And the students that I taught in these 5 days aren't experts at the end, but they definitely have a broad knowledge about Rust and its basics. And with basics, I also mean like multi-threading and asyncs. So they have a brief introduction to most of the topics that you would need, but their knowledge is not deep. So they can just go home and read about the other topics that they need. But it's definitely achievable in 5 days that you have proper knowledge. And finally, I've showed you that teaching resources are available, and we have decent ones. So my question at the end is, what are you waiting for? Go ahead and teach Rust in your organization, whether it's your university or company or whatever. Go ahead and share your experience while doing so. All right.
Before we come to the questions, I will take the microphone from the front so we can give that one to the audience, and then we use the phone recording for the answers. I hope it works. But also, I have a few gifts if you want them. They're maybe too small. That was the only size we have left. We have some Hacker Stolz socks. If they're too small, you can give them away as well.
Oh, that's cute. Okay, thanks.
But we also, if you want some of them, I brought a few Rust-themed stickers.
Nice.
I mean, if you can count Tauri Rust-related.
Yeah, of course, of course.
And for anyone else, we also have a few stickers for our association, which you can take a look later.
Thanks.
Thank you very much for the talk. I found it really interesting and really well done. You can clearly see that you have previous experience in speaking.
Thanks.
So I will just take this one. Are there questions? And yes, where? Okay, we just start at the back, and then I go from there to the front.
Maybe before we start, maybe show of hands. That's a method I mentioned. Who of you is thinking about teaching Rust in their organization or whatever? So, especially after this talk, or did I demotivate some of you? All right, so we have a couple of hands. Especially you should ask me, and I will share my contact then. All right. So.
Yeah. So first, thank you for giving this presentation. I found it inspiring. And my question would be, like, you already mentioned that it's important to tailor the course around the group you want to teach. And in my organization, we are mainly having C++ evangelists, people who are very, very deep in the language. It's even hard to convince them to get to this course, I would guess. So the question would be, is there any resource that you can recommend where there are typical examples where Rust either outperforms the C++ version or explicitly shows that it's much better than C++? I mean, I already came up with some examples, but I guess maybe there is some resource I can tap into without making too much noise about myself. Like, you know, like I would be happy to have a course specifically tailored to such low-level engineers, maybe making the switch from C++ or C to Rust. Like, is there something that you can recommend?
No, sadly, there is nothing I can recommend. There is a video that I watched and inspired me at the beginning to begin my journey with Rust, but sadly I can't remember the name of it. It's at one conference about Rust itself, so but it doesn't really matter. You can't motivate them when talking about performance, because they already know they have the maximum performance when done right. So rather focus on doing something right and producing correct code, especially when having concurrency. So for many, if they aren't really hardcore C++ fans, just mention that Rust doesn't have any seg faults and they will be sold. So if they are more advanced, tell them, do you know about data races? In Rust, it's proven that you will not have any data race. Do you want to know how this is done? So that's maybe an example of how to motivate them. So, but if you tell this to someone that is who is only familiar with Python, then they would say, okay, cool nerd. So just tailor this to the audience. But I don't have any specific material to point to.
And I have another question, if it's okay. I would like to know, is there a size of people that you can recommend? Like, what is too much? Like, what is the top 20, 30 people? How much do you think is valuable in a course?
Mm-hmm. That's a good question. If we are talking about workshops, this is a one-time thing. And at the Congress, we had about 30 participants, I think. You can't manage this amount of people alone, because some of them have individual questions and so on. So it's much better to invite other stations so that they can help you. And that's what we have done. So go there with 5 people that are already experienced with Rust, and then you can actually offer it for, I don't know, 40, 50. I mean, it really depends on how many helpers you have. Otherwise, for the course, I would say 20 is a good maximum, but I can also imagine that this is too much. So for me, they had about 12, 13.
For the 5-day course then, right?
For the five-day course, yeah. I mean, of course, at some point you can't answer every question, so you need to think about that. So I would recommend to stop at 20.
Okay, thank you.
Okay, the last 2 rows, I think there was another hand here, or? No, then we continue to.
Also wanted to thank you for the talk. It was really, really cool. I spent a lot of my, I guess, side time in my company working on our kind of Rust infrastructure and tooling. And an issue we have is kind of knowledge of our internal projects or kind of frameworks that you can use. And Rustling seems really cool as kind of like this kind of guided approach into deeper and deeper complexity. I'm wondering if there's any opportunity to, say, like introduce like packages or extend Rustlings to support the idea of like, oh, you want to connect to this service, well, we have this package, and here, try to use it. As like less of the .rs kind of file, like single file sort of test, more of like, here's a package, what's wrong with it? So my first question is, do you have any ideas of how you might be able to extend Rustlings? Because I think it'd be really great to have some sort of guided Rustlings in my company. So can you extend Rustlings to like more of like a crate or package level? And have you helped or worked with any organizations in doing that before, or helping them build things like that? Or know of it?
So the first question is, can you use Rustlings to create exercises that aren't only built, that aren't only one file, but that are packages, or let's say crates? The answer is yes, this is possible, because every exercise is a binary. That's how it is currently done. And binaries can have other files, so you can include other files in this binary, but it's not really a crate, so you can't have a library. So I think this should be enough. And what I should mention at this point is the support for third-party exercises. This is something that I have worked on and I'm very proud of. So you can use Rustlings to create third-party exercises, and you basically use the same program which you installed. Just run Rustlings on the third-party exercises, and then you can work through them. And until now, we only have these 2 translations. But if you create another set, which is also something that the community could want to have, then please share it, and I can put it in the README. So yes, you can create exercises, custom exercises with Rustlings, and they can contain multiple files. And for that, refer to third-party support. The second question was about if I have...
Have you heard of any companies kind of trying to use Rustlings internally?
No. So, quick answer, no. But I would love to hear about that. I mean, the third-party support is rather recent and not many people know about it. So, of course, if you want to contribute some exercises to Rustlings itself, you are very welcome to do so. Just open a PR, or of course open an issue before, and we can include that. But if it's too specific, then third-party support is the way to go.
Yeah, thank you.
Okay, who else was raising the hand before? Yeah.
I wonder how, if you incorporate some kind of AI tools for the teachings. I asked because I was learning Rust on my own without Rustlings. I was reading the book. Same time I was trying to go the coding first approach. Somehow, like you said, it's difficult to get around without big knowledge. And I found that it's very helpful to just copy paste the error messages into ChatGPT and get very good answers, and they're really helpful for learning because they're also explained. And I can imagine that it's very helpful for any student to learn like that.
Mm-hmm. I don't have experience with using AI while teaching, and personally I wouldn't recommend that. Personally, I'm not a fan of AI when coding, so that's a rather personal thing. But when talking about copying compiler errors into some AI, to understand it, what I focus on during such a course is how to understand these compiler messages, because the first thing that I highlight when I run a code snippet is, let's do a small mistake and see what the compiler tells me. And I show them how that everything is colored, and it tells me to modify this, or here's the error. Because to be honest, when using other programming languages, I tend to just copy the error and put it in the search engine to read on Stack Overflow. And with the availability of AI, it would be a good opportunity to use AI for that. But in Rust, I've never found a use case for that, because the error messages are actually very good, at least in my opinion. And if you think that an error message is misleading or confusing, then it's a bug. It's considered a bug, and you should go ahead and file an issue. So that's something I really focus on during the course. And when seeing error messages like this is moved, I don't tell them, so an object is moved, they can't understand it on the first or second day, but then after explaining ownership and borrowing, I go back to this exercise and tell them, this is what this error message is telling you. So this is very important to be to look at the compiler as your friend. So, but to go back to the original question, I don't really have experience with AI. It might be useful, but I focus more on understanding the error messages by humans.
Thank you.
Okay, so 2 questions from me. So first, I'm seriously considering giving a Rust course next, or maybe 2 semesters or so. And so one option would be probably giving some kind of seminar with 90-minute slots per week. So I guess taking like the blueprint of the 5-day course would probably be the option to go, or what do you think about that? Or do you think like more like a condensed block seminar kind of thing where we rock everything like in your vocation course in 5 days or so is more the way to go? What do you think about that?
So how much time do you have again? I didn't quite get that.
So if you have a seminar, you probably have like over 3 months, like 1 90-minute slot per week. So this would add up to, I don't know, like maybe like 12 sessions or so.
I would rather recommend checking out TeachRS first, because it has a better focus on teaching in a long term, and not really in the form of a crash course where you are teaching in a couple of days. But I think comprehensive Rust is also useful for this. So, I mean, as I said, if you think that it's not a good fit, you can always remix it, just move some sections around. That's also something that I've done. And maybe if you have 90 minutes, then you could have one of these sessions for every seminar session. So instead of morning, you say session 1.
Okay, so how many minutes is one of these morning sessions supposed to be?
That's a very good question, and it is a rather new feature in comprehensive Rust, because okay, they show you at the beginning how much time it takes. This is something that I really value about comprehensive Rust. So of course it's only an estimate, and it depends on the amount of questions that you get, but you can work with this estimate to redistribute and reorder sections as you want. And of course, when teaching such a course, you need to be flexible. So if you need more time for one topic, then you can see, okay, the next topic doesn't require a lot of time, so that would be also something to take care of. But,
All right, thanks. Now for question number 2. So one of the unfortunate things when you're teaching at the university is you have to give grade at the end of the day. All right. So what do you think would be like the best option for grading students?
This is something that I don't have experience in, so but I mean, maybe some exam at the end would be helpful. I'm really not a fan of coding on paper, so maybe just ask some questions about ownership and borrowing and related topics. So questions related to understanding and not really coding itself. But yeah, really I have no experience here. So the vacation course that I have done is completely voluntary, and people go there because they are interested in this topic and they want to learn about it, but that's it. Yeah. Maybe get in touch with the people behind TeachRS, and they have also this website. I should mention it as well. Rust.edu.org. So it's an initiative for Rust education and academia, but they aren't really active. That's why I didn't want to include it as an important resource, but definitely check it out. There might be some people behind it that have experience with giving marks at the end.
All right, thank you.
Who else? On the second floor? Then continue here.
So maybe something which is not asked often, but we are talking about teaching developers, teaching somebody who is interested. But what about teaching the manager, the product owner, about why Rust is important and why we should maybe invest in Rust and invest in time to teach other colleagues? I don't know, did you make some mind about arguing with managers about the usefulness of Rust? Or
I don't have experience with selling Rust to managers, but what I would definitely recommend is to avoid technical aspects and focus on the aspects that are also mentioned on the website. So if I go to the Rust website, rustlang.org, then you see here how you should be selling Rust. So focus on performance. So if you have better performance, better efficiency, then you spend less money on servers and so on. That's obvious. Reliability, I mean, just explain it and how this improves the quality of your products. And finally, productivity is one of the major points here when talking about the benefits for developers from a manager's perspective. And I can definitely refer to studies done by Google where they compare the productivity of their developers when using Rust and when using other languages like Go. And they say that people are at least as productive in Rust compared to other languages, and they have many studies where they say where they show how the safety improves, what strategies they would recommend for adopting Rust and so on. So there are also some talks online. Just look for Rust Google adoption, I would say, and you will find some good.
thank you.
Any more questions? Then I think we can give another round for applause. Okay, so I'm not sure how much of a time pressure we have. I'm not sure, Roland, how long?
I'm fine.
Okay. So then, yeah, can stick around for networking, discussing teaching Rust amongst each other, amongst Mo. I'm not sure how long Mo can stay because he probably has to catch a train at some point.
At some point.
Okay. Yeah, someone generously organized something to drink, so feel free.